Dear students, welcome back to chemistry class. Today, let us continue the lesson, Is matter around us pure? Let us revise what we have learned in this lesson. In the previous class, we have learned the methods of separation of the components of a mixture. Among that methods, 4 methods we have studied in the previous class. What are they? Evaporation. It is used to separate a volatile component or a solvent from its non-volatile solute. Example, separation of colored component or a dye from blue or black ink. Then we learn what is meant by centrifugation. It is used to separate particles of different densities from a solution. For that we have learned the example, separation of cream from milk. Then using separating funnel, it is used to separate a mixture of 2 immiscible liquids. We have learned how to separate kerosene oil from water. Then we learn the method of separation, sublimation. It is used to separate mixtures that contain a sublimable volatile component from a non-sublimable impurity. For example, we have learned how to separate a mixture of salt and ammonium chloride. Today we are going to continue this topic, that means the methods of separation of the components of a mixture. Today we are going to learn 3 more methods. One is chromatography. It is used to separate the solutes that dissolve in the same solvent. Example, separation of dyes in black ink. Next one, we are going to learn what is meant by distillation, for what it is used. It is used to separate the components of a mixture containing 2 miscible liquids that boil without decomposition and have sufficient difference in their boiling points. We are going to learn how to separate acetone and water from their mixture using the method of distillation. Then fractional distillation. If the difference in boiling point between the miscible liquids, if it is less than 25 Kelvin, instead of distillation, we are using the method of fractional distillation. For example, separation of different gases from air, we are using the method of fractional distillation. And to separate different fractions from petroleum products, also we are using the method of fractional distillation. So, to separate the different fractions from petroleum products, also we are using the method of fractional distillation. So, let us start with the separation of dyes in a black ink. How is it done? It is done using the method of chromatography. Let us perform an activity to do this chromatography to separate the dyes in black ink. So what we have to do? We have to take a thin strip of filter paper. This is a thin strip of filter paper is taken. Draw a line on it using a pencil approximately 3 cm above the lower edge. So from the lower edge, above 3 cm, we have drawn a line using a pencil. Put a small drop of ink. It is water soluble. That is, from a sketch pen or a fountain pen we can take the ink. A small drop is put on the line. Let it dry. Next what we have to do? We have to lower the filter paper into a jar or a glass or a beaker or a test tube containing water, so that the drop of ink on the paper is just above the water level. So here we have lowered this filter paper into a jar. We can take a jar, otherwise you can take a glass or a beaker or a test tube you can take containing water, so that the drop of ink on the paper is just above the water level. So here you can see the drop of ink is just above the water level and leave it undisturbed. So watch carefully. What we can see as the water rises up on the filter paper. Let us see. So once again, what we have taken a filter paper and 3 centimeter above the lower end of the filter paper, we have drawn one line with a pencil and put a drop of ink on that, water soluble ink. Then lower this filter paper into water which is taken in a glass jar or a beaker. Then such a way that the drop of this ink is just above the water level. So here the water rises up through the filter paper. As the water rises up, what we can observe here? We can see that when the ink that we use has water as a solvent and the dye is soluble in it. So as the water rises up on the filter paper, it takes along with it dye particles. So this dye means different colors. The black ink is containing different color dyes. So when the water rises up, it takes the dye also along with that. The colored component that is more soluble in water rises faster, and this way the colors get separated. So what we can see here, the ink that we use has water as a solvent and the dye is soluble in it. As the water rises upon the filter paper, it takes along with the dye particle. Usually a dye is a mixture of 2 or more colors. So the colored component that is more soluble in water rises faster, and in this way the colors get separated. So in this, can you say which is more soluble color? Which is on the top? More soluble color along with the water rises up. So which is least soluble will be at the bottom. So this process of separation of components of a mixture is known as chromatography. Let us see what is meant by chromatography. Chromatography is the technique used for the separation of those solutes that dissolve in the same solvent. So from different solute which is dissolved in the same solvent can be separated using the method of chromatography. These different solutes are having different solubility in the solvent. So let us see the applications of chromatography. Actually the name chromatography has derived from the Greek word chroma. Chroma means color. So first it was used to separate the colors. That's the reason it got the name chromatography. Let us see the applications of chromatography. It is used to separate colors in a dye, pigments from natural colors, and it also used to separate drugs from blood. So we have learned one method of separation of that called chromatography. Next we are going to learn how to separate a mixture of two miscible liquids. Already we have studied how to separate a mixture, the components from a mixture of two immiscible liquids. Which method we are following? We are using the separating funnel. So to separate the components from a mixture of two miscible liquids, we are using the method of distillation. So distillation, here the principle behind distillation is evaporation and condensation. Let us see how this is done by taking the example of acetone and water mixture. So how we can separate the mixture of acetone and water from their mixture. So let us perform an activity. Take the mixture in a distillation flask. So this is a round bottom flask, a distillation flask. In this mixture has taken mixture of acetone and water. Arrange the apparatus. So how we have arranged the apparatus? We have here with a cork. We have covered this, and through this is a one hole cork. Through the hole we have inserted a thermometer, and this is called condenser. So here you can see here two outlets, one outlet and one inlet. So water outlet, this is a water inlet. So this is connected to a tap. So this cold water, that means water at room temperature, not hot water, it will be circulating continuously. and this is connected to the sink or wash basin. So continuously the water will be circulating here. So what is happening here? Here we have taken the mixture of acetone and water. So these two components having different boiling points. So which will boil first? Which is having higher boiling point or lower boiling point? The liquid which is having lower boiling point boils first. So compared to water, acetone is having boiling point less. So acetone boils first. And we know that when a liquid is boiling, it's show the same temperature until all that liquid boils. So here when acetone is vaporizing or boiling, it will show the same temperature. So the vapors of acetone is formed here. It is passing through the condenser. It get cooled. So when the vapors get cooled, what forms there? It forms a liquid. So this acetone, it liquefies and this acetone is collected here. So what will be left in the distillation flask? Water is left behind in the distillation flask. So once again, we have taken the mixture in a distillation flask, the mixture of water and acetone. We have arranged the apparatus like this, and when we are heating this, what happens? Heat the mixture slowly, keeping a close watch on the thermometer. That means first the thermometer show a constant reading until all the acetone vaporizes. The acetone vaporizes and condenses in the condenser and it is collected in the beaker. And water is left behind in the distillation flask. So let us see. This method is called distillation. So let us see what is distillation, for what we are using this. Distillation is used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling point. That means if the difference in the boiling point between the components is more than 25 Kelvin, if they are two miscible liquids, to separate them, we are using the method of distillation. So if the boiling point is less than 25 Kelvin, we are using the method, difference in boiling point is less than 25 Kelvin, we are using the method of fractional distillation to separate a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 Kelvin. Fractional distillation process is used. So example for fractional distillation, we are using to separate different gases from air, and also to separate the different fractions from petroleum products. Also we are using the method of fractional distillation. Let us see how it is done. The apparatus is similar to the distillation. Only the difference here, we can see one fractionating column is fitted in between the distillation flask and the condenser. So a simple fractionating column is a tube packed with glass beads. The beads provide surface for the vapors to cool and condense repeatedly. So if the liquid containing more than two miscible liquids also, we can separate them by the method of fractional distillation. If the difference in boiling point is less than 25 Kelvin, instead of distillation, we are using the method of fractional distillation. Why these glass beads are used here? It is these glass beads provide surface for the vapors to cool and condense repeatedly. So which is having least boiling point, that will vaporize first and it is collected here. After condensation, it is converted to liquid and collected here. Then the next boiling point, the liquid which is having highest boiling point is collected at the last, or it is left over in the distillation flask. So we have covered today the topics, 3 methods of separation of the components of a mixture. Chromatography, it is used to separate the solutes that dissolves in the same solvent. Here we have learned the example of separation of dyes in black ink. That means black ink consists of different colored dye. How to separate them using the chromatography we have learned. Then we have learned distillation. To separate the components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling point, we are using the method of distillation. We have learned the example how to separate acetone and water from their mixture. Then we learned fractional distillation. It is used to separate a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 Kelvin. So to separation of different gases from the air and separation of different fractions from petroleum products, we are using this method. Hope you understood today's class. Thank you, children.